OXYZ is a parallelogram. We see going from O to X is the vector A, going from O to Y is the vector B. P is the point on O to X, such that the ratio between O to P and P to X is 1 to 2. And in a similar way, R is the point on O to Y, such that the ratio between O to R and R to Y is 1 to 3. So our goal is to work out in its simplest form the ratio ZP to ZR. So now the first thing we're going to do is label the diagram. So we know that O to X, if I label it on here, that whole thing is going to be the vector A. And if I do O to Y, that whole thing is going to be the vector B. So firstly, I'm going to look at this line here. So look at the ratio OP to PX. So we've got the parts 1 and 2. So add them up. In total, we've got 3. So I'm first going to look at O to P. So because we've got the 1 here, it's going to be 1 out of the total, so 3. So a third. Multiplied by, what do we have in total? Well, the whole thing is this vector A. So multiplied by the vector A. Now, let's have a look at the other part. So P to X, it's going to be the exact same thing. For this, we've got 2 out of 3. And it's going to be out of, so multiplied by the whole thing, which is the vector A. Now let's do the same for the second line. So R is a point on O to Y, such that OR to RY is in the ratio 1 to 3. So again, adding that up to get the total, what we're out of is going to be 1 plus 3, which is 4. So O to R, that's going to be 1 out of 4, multiplied by, what we got in total, the vector B. So a quarter of the vector B is this portion here. So now, taking a look at R to Y, the rest of it, we have a look, that's going to be 3 out of 4, multiplied by the vector B. And this makes sense, because if we add up 2 out of 3 multiplied by A, and 1 over 3 multiplied by A, we'll get A, and that makes sense, because the whole thing in total should just be A. And same for this one here, if we add up a quarter B, and 3 over 4B, we get 4 over 4B, so just B, which is perfect, because that's what it should be, the whole thing. Great, so now let's draw attention to this part here. So I'm going to focus on ZP first. So how do we get from Z to P? Well, the interesting thing is, because we got a parallelogram, this here is the same as this here. So to get from Z to P, we can do A, we can do minus B all the way down here, and then plus 1 over 3 multiplied by the vector A. So writing that out here, we're going to have A minus B, because we're going backwards, the opposite direction to the way the arrow is pointing, and then we're going plus 1 over 3 multiplied by the vector A. Great, so now we've got the other part of the ratio, Z to R. So again, we can go Z to Y, so A, and then go back, but this time we only want to go back this far. So we're going to go back minus 3 over 4 multiplied by the vector B. So writing that out, we're going to have the vector A and minus 3 over 4 multiplied by B. So let's write these in the ratio form, giving us this ratio here. And what I've done, just to make it a bit simpler, is when we've got like a third multiplied by the vector A, I've written it like this. 3 over quarters multiplied by the vector B, I've written it like this. But it means the exact same thing. Now I'm going to manipulate this a bit. So we can see, okay, on the left-hand side here, we've got a component here and an A component here. So I'm going to try and merge them together. So what I've done here is I've multiplied the top and bottom of this element by 3. So it's the equivalent fraction. But what that now means is I've got a common denominator here and here. So that gives me 4A over 3 minus B. And then the same here on the right-hand side of the ratio. Now we want to see how both these parts relate. So I'm keeping this part the same. For this part here, I'm going to factorise out 3 over 4. If I do that, I'm going to get 4A over 3 minus B. Now that's a bit complicated, but hopefully you can see that if we multiply 3 over 4 back into the bracket, we multiply this in this term, we'll just be left with A. Perfect, so it's what we want here. And multiply this and minus B, we'll get this. So these are completely equivalent. But what we can now see is that all of this is identical to all of this. And what is all of this? Well, on the left-hand side, we've got ZP. So I'm going to say ZP, and then we've got 3 over 4. But as I said, this, we can see, is the same as ZP. So I've got ZP to 3 over 4 ZP. So now for the final part, what we got on the right-hand side originally, well, that's ZR. So I can say that ZR equals 3 over 4 ZP. Lastly, we need to get the actual ratio. So I'm going to let ZP equal the value 4. And the reason I've done that is it now means we've got 3 multiplied by 4 over 4. because I've replaced ZP with 4. This means that these 4's cancel, so we got that ZR equals 3. So wrapping this all up, since we want the ratio of ZP to ZR, our final answer is 4:3. Since the value of ZP is 4 and ZR is 3. So we get our first mark up here for all the work we did getting the vectors on the diagram. We get 2 marks for this step here, so getting ZP, ZR. We get our 4th mark for getting down to this point. So for the process of writing ZP and ZR as multiples of the same vector, so in this case we've done it, so we've got ZP and ZP. And the final mark for the correct answer of 4:3.